Hi, welcome to Complete Graph, which is used to construct the spanning trees. So, how many number of possible spanning trees available in given complete graph? The complete graph, in the sense, each pair of vertices are connected with unique edge. For example, the one is connected with all other three vertices here, and 4 is also connected with all other vertices here. So like this we can have each node is connected with every node in the graph that are making the cycles in the given graph. In this case we will have number of possible spanning trees are equivalent to number of vertices power number of vertices minus 2. For example, the given graph is having 4 vertices and each vertex is connected with all other vertices with the unique edge, right? So number of possibilities here v power v minus 2, that means number of vertices are 4 power 4 minus 2, so here 16. So the first one is represented here, the removing the this cross edges and also the edge between 4 and 3. Then you can draw different kind of spanning trees with by removing the cyclic edges, right, which are forming the cycles in the given graph. So based on this we can say number of possible spanning trees are number of vertices power number of vertices minus 2. Here the properties of spanning tree is, here the connected graph G can have more than one spanning tree. That means the number of spanning trees are equivalent to number of vertices. All possible spanning trees of given graph G have the same number of edges and vertices. For example, you look at here, all the spanning trees, all 5 spanning trees are having same number of vertices. All spanning trees are having 5 vertices and all spanning trees are having 4 edges, 1 2 3 4. So 4 edges. All the possible spanning trees are having same number of vertices and same number of edges, and the spanning tree does not have any cycle. All the spanning trees are not having cycles in its structure. Removing one edge from the given spanning tree will make the graph is disconnected. For example, here this is the spanning tree. If I remove this edge from the spanning tree, it will make disconnected graph. So the 3 and 5 will become one graph, and I mean one portion, and these three nodes will become one portion. So the entire graph becomes disconnected graph. So here when we are adding one edge to the spanning tree, wherever you are adding one edge, for example I am adding one edge from 3 and 2, it is forming the cycle. Suppose I am forming one edge between 4 and 5, it is forming the cycle. If suppose I am adding one more edge from 1 and 2, right, so it is also forming the cycle. When you are adding one edge to the spanning tree, it will create the cycle, the or circuit, or another terminology is loop. So the spanning tree is maximally acyclic graph, right? So in complete graph we can remove maximum number of edges will be e minus number of vertices plus one edges for getting the spanning tree. So complete graph, here we will have more number of edges, that means each vertex will connected with other vertices, all other vertices in the given graph with unique edge. So there is more number of edges. So the given formula is number of edges minus number of vertices plus one edges to be removed to remove the acyclic graph. That acyclic graph is called spanning tree. So here we should follow these properties whenever we are constructing the spanning tree for given graph.